Hello. Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GRE out of this book here. Practicing to take the GRE General Test, the 10th edition. If you do not own this book already, purchase it immediately. The problem that I'm about to solve is the one that you're going to find on page number 280. Number 280. Let's take care of this here. Just 1 second. Page 280, the very first problem on the page, number 11. As I keep reminding you over and over again, this is the old-fashioned paper and pencil exam format where the question used to be arranged in the order of difficulty. Used to be, not anymore, not in the computer adaptive exam that you're going to take. This is, as I said, the good old days. In which case they used to give you 15 questions in a set. 15 quantitative comparison questions, which meant that the first 5 were easy, 6 through 10, the next 5 were medium, and 11 through 15 were supposed to be hard, supposedly hard. This is number 11. What it means when somebody says it's a hard question on a standardized exam, what does it mean for an exam to be a hard question? A hard question, a difficult question on the GRE or SAT or GMAT or whatever, whichever standardized exam you're taking, a hard question does not necessarily mean that it involves complicated mathematics. Let me edit that sentence. I used the word, I qualified it by saying necessarily. Let me edit that sentence. Hard question does not mean that it involves hard, tough mathematics. It doesn't mean that it involves calculus or differential equations or analytical geometry. Math is very simple, very straightforward. All it means is that you have to do 1 or 2 extra steps. You have to be extra careful in your thinking. All they're trying to see is how well you think. That's all they're trying to see. They're not trying to see how much math you know. As I said, math is very fundamental. For example, in this one, more than half the people who took the exam missed this one. 55% of people got this question wrong. Only 45% got it right. We'll see in a second exactly what is going on here. They tell you the area of a circular region. An area of a circular region is just a fancy way of saying area of a circle. The area of a circle with a radius of 1/4 of a meter. Area of a circle with a radius of 1/4 meter. But before I do any work at all, I'm going to actually figure that out right now. Well, I hope that you know all the basic formulas. You have to know how the area of how to figure out the area of a triangle. You must know how to figure out the area of a circle. You must know how to figure out the area of a cylinder. These are basic things that you have to know for the exams. You can't get away from them. You have to know them. For example, area of a circle is simply pi r squared. That's all. Pi r squared. Well, we're told that r is 1/4 meter. So 1/4 squared, r squared. That's how many it is. 1/4 raised to second power is going to be 1/16. So it's just pi over 16. That's just how I make my pi. I know it's not the right way, but that's just the way I do it. Pi over 16. And what are they calling that quantity? They're giving it a name. They christen it x. This here, let me read again what it says here. The area of a circular region having a radius of 1/4 of a meter is x square meter. So I'm going to call it x. There we go. If you don't know what that word, or if you don't know what that word means, look it up. I just used it. I said they christen it X. They call it, they name it X. They label it X. So fine, this X. What is it that they want me to compare? They want me to compare in column A. They give me this x, which I now know is this quantity, versus column B. They give me 1/4. Well, let's take a look at them. Well, the very first thing I'm going to do is, because I have, well, we don't need this x here, so I'm going to get rid of it. We don't need this x. Let's bring this pi over 16 to the middle of it. Very first thing I'm going to do is, because I have a denominator of 16 here, it will make my life much easier if I had the same denominator here. So let's convert this 4 into a 16 by multiplying top and the bottom by 4. It becomes 4 over 16. I basically multiplied the top and the bottom by 4. So now I'm comparing pi over 16 versus, I'm going to erase now, I don't need it, versus 4 over 16. Now let's digress here for a second. And again, if you do not know what digress means, look it up and learn it. Digress just means to go off a topic for a second. Let's digress here for a second in this margin here. So I have to compare these two quantities. I'm going to bring them closer so I have the room here. So we have to compare pi over 16 versus 4 over 16. Pi over 16 versus 4 over 16. Column B, column A. Well, if I ask you which quantity is bigger, 20 or 30, which quantity is bigger, which 20 or 30, and then instead of that, if I ask you which quantity is bigger, 20 over 5 or 6 over 5, because I'm dividing both quantities by the same number, as long as you multiply or divide, as long as the quantities in the two columns, listen very carefully, as long as the quantities in the two columns are being multiplied or divided by the same positive number, that quantity plays no role in it. For example, if you ask me which quantity is bigger, 20 over 5 or 30 over 5, 5 plays no role in it. Basically, what you're asking me is which quantity is bigger, 20 or 30. That's all. Similarly, if you were to multiply the both sides, similarly, if you were to ask me which one is bigger, 2 plus 3 or 4 plus 2, let's make it a little bit interesting. It doesn't matter. It doesn't matter. Now, times. I need more room. I'm getting too crowded here, and I'm probably running out of time now. I'm going at a too leisurely of a pace, and that makes me nervous. Just give me a second. I'm going to look in the back of the camera so that it calms my nerves down, because I don't want to. Just give me a second. Yes, I'm over 8 minutes, almost 9 minutes into this. I'm going to wrap it up. If I have a 3 plus 1 versus 5 plus 2, and if you ask me which quantity is bigger, and then at the same time, if this side is multiplied by 37, by say 10, and this side is multiplied by a 10, that 10 plays no role in it. As long as it's multiplied by the same, as long as it's multiplied by the same, unless you multiply by the negative number, then it changes. Then it causes the change in the direction of the inequality. For example, 3 is greater than 2, but if I were to multiply this side by negative 2 and this side by negative 2, then of course negative 6 will be smaller than negative 4. So as long as there are no negative number involved, as long as this multiplier is positive, you can just cross it out, because it plays no role in it. So similarly here, you're asking me to compare which quantity is bigger, pi over 16 or 16 or 4 over 16. Well, since both quantities are being divided by 16, the 16 plays no role in it. 16 plays no role in it. So basically, what you're asking me is which quantity is bigger, pi or 4? And I hope that you know that pi is simply 3.14. 3.14, of course, which is less than 4. 4 is bigger than 3.14. The answer is B. That's all. That's all. I think I made a little bit too much fuss about it than I needed to be, but that's okay. I hope you got something out of it. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, face-to-face tutoring, or through over the phone or through the internet, go to my website at www.prep, for4gre.com, and send me an email. Or you can go to www.KeshwaniPrep.com and send me an email. All right? Thank you.